Okay, so next we're going to talk about tessellation and displacement. That is the more expensive version of the parallax occlusion mapping and also the bump mapping. So how it generally works is tessellation takes whatever the vertices of the mesh is. So if I go here into our wireframe, I've already brought in this very high poly mesh plane that has I want to say over 1,000 triangles, give or take, maybe 1,200, just to kind of show off the effect. So right now you can see that this is how much it has on it, and then like when you go further and further, it will start to LOD out some areas of it. Um, but the thing is that it still doesn't have enough detail to really kind of adjust values on the plane. So like if I go back here and I would apply like the same thing here, the normal and the albedo and everything else, it still wouldn't look right. So actually, let me go in and where is it at? Where's the parallax material at? I think I left it in here. Yes. So I'm going to copy all the stuff from the parallax material and I'm going to create a new one. New material. And then this one's just going to be called displacement underscore mmat. So let me go and hit copy and paste and start plugging some of these guys in. We're going to delete that PDO depth thing, and we're going to delete all of this parallax valuing. And so, well, we delete this one, and then we have this guy still. Let me just plug him back in. And then let me show you guys how to set up for tessellation. So for this material, all you have to do is go down here to where it says tessellation. You can change it to one of two different types of tessellation. Flat tessellation tries to kind of subdivide it normally, like how a normal modeling program would do, where it tries to just quad split into fours. And then there's flat tessellation or the PN triangle tessellation, and that one, what it does is it kind of does a random bit of subdivision with triangles to try and adapt to a shape. And then what we'll do next is we'll turn on crack-free displacement. So in case something extreme happens, it tries to compensate by deleting or not deleting by basically what it does is it takes the vertices that are breaking and it tries to normalize them a little bit so it doesn't cause that break. It's still not perfect, but it's still something. And then here is max displacement. So this is you can set your maximum value of height in a sense. So I'm setting it to 1. So let's hit apply real quick. And then honestly, Tesla, now that we have this option already set up, it gives us these two values, world displacement and tessellation multiplier. So if I go here, convert this guy to tessellation um, multiplier. There we go. Plug him in, hit save. Save again. Okay. Now let me go and create an instance. This will be our cobble, stone, DS for displacement, and then I'm at. Let's drag him in. I believe we'll do UV tiling, I think 2. I think that's how we can get to like the similar size to this guy. So now we have our cobblestone all set up. Now let me show you, let me change this to wireframe. So we still have our normal mesh. Now let me hit Tesselation 1 and ungrab it. You can actually see that the tessellation is now starting to work. You can see how like this kind of randomized set of triangles and stuff. And then if I do tessellation 2, it tries to sparsely add more dense value to it. You can do like 4 maybe, and it just keeps trying to add more and more and more. Uh, there we go. Yeah, you can see like there's so many polygons that you can't even see the differentiation of it. So let's go back to 1. But the one problem you're going to notice is you can still see the tessellation still there. It doesn't LOD out like a normal mesh does because it's not handled through the mesh. It's a type of effect that's applied through the shader. So what we need to do is we need to start kind of culling the tessellation value itself. And one way of doing that is you can use distance as a way. So what we're going to need is we're going to need 2 nodes to try and help figure out from our perspective as a character and then also as a mesh where the distance between the 2 is. So the first one is going to be our camera because no matter what, your player is going to have a camera. No, not that one. Camera position, world space. So this is going to give us our camera's position. And then we're going to just need a normal world position to figure out where the mesh's position is within the world space. So we have our 2 values here, and then we're going to subtract in order to get the difference between the 2, and that's going to be part of our link. So we have the information, but now we need to create vector 3 value of this as a link. So we have our information in vector 3. Now we need to adjust it to a length value. So let's type in vector. So what this basically is creating is it's going to create a vector from our position of the camera to the distance where the mesh is in a sense. And when we get to a certain point in this vector, it will start to cull off, or anything past this vector will cull off and not have tessellation to it. And then next thing we'll do is we'll divide, because we need to divide this value with, let me go in here. We'll change this to fade length. And we'll do like 1500 for him. So whatever this value of length is going to be, it's going to divide, and then this is how we're going to get the adjustability of the link itself. And then if I actually go and I kind of preview this value, you'll see that it is working, but it's kind of doing the opposite of what we want. We want it to be when you're farther away, it turns black, versus when you get closer, it turns white. But right now, it's the complete opposite. So what we're going to do is we're going to just do a 1 minus, and that's going to invert our value now, because what we want to do is we want it to be used as a value that we multiply with. So if it's black and we multiply it, it turns off tessellation, but when it's white, it turns on tessellation. So we're going to take this guy and we're going to multiply him with our tessellation multiplier. And then that's how we get our normal turn on value. And then what we're just going to do is we're going to just apply a normal switch parameter. I can spell switch. Static switch parameter. And then I'm going to hit the default value. And this is going to be enable tessellation. Boom. And then boom. So now when we do our tessellation multiplier, we already have a tessellation multiplier of 1. So we have that guy already. But as you can see, the farther he gets, it starts to tessellate out. So actually, I can adjust that length too. So do 1,000 or even 500. And it's not just like based off of distance, it's a radial value. So if I start going down like this, it actually starts to adjust in an equal distant value around you. So it's almost like there's like an aura around you, not just like wherever the camera is. It's the position of the camera and not the vector of the camera's screen space. So that's how you would at least curve that value of performance, because that's going to be one of your biggest problems with tessellation, at least. So now let's go in and let's plug in our value for displacement. So what we're going to need is I'm going to copy this guy and I'm going to convert him or tell him he's going to be a height. And then we'll just plug in base height. Oh, yeah, it also turned that one. I thought I changed the name. There we go. Over M. There we go. So next thing we're going to do is we're going to do cheap collision or cheap contrast, sorry. We're going to take the red channel of this guy because we need the first channel since it's a grayscale value. We're going to do our first parameter will be displacement contrast. That way we can actually adjust the kind of, in a sense, almost grayscale values that we're going to get out of this texture. And then we can kind of crunch those values up a little bit if we want. And then next, we're going to do another multiplier. But this is going to be the actual strength. So this will be displacement intensity. We'll just set him to 1. Actually, no, we're going to set him to 0. And then next thing is we're going to do one more. This one's going to be very good in case we have an issue with depth. It's going to be an offset. So this last one that we did before was the intensity, and that was going to adjust how far the difference between the vertices is going to be. This is going to adjust the height of that vertice so that it maybe it might be clipping too far along inside of a mesh. You can lower it or even higher, make it higher so that it actually hits your player's feet if it doesn't already. So we're going to add that value to it. And then just move some adjustment a little bit. And then we're going to need just one last thing. And this is the most important one. If you don't have this, it's not going to work. It's not like tessellation where you can just plug in a scalar and it work. You need to have your vertex normal world space, because this will allow and get the information of the vertices that are in the mesh and allow it to be moved based off of all this information. So plug that in, and then we'll plug him into our world displacement and hit apply and save. Let's go to our instance, and then let's get out of our wireframe. Looks like our UV tiling is set up in a weird way. So let's hit 2. Okay. So there's no displacement as of yet, and that's because we haven't turned on anything. So first, let's do an intensity of about like 4. And then let's also bring in the height map, because if we don't do that, it's not going to actually work. So we have all of our cobblestone set up. Let's enable tessellation. Now let's do a multiplier of 2. Bring our value up to 10. You can actually see the values now starting to show up. Actually, wait, let me do something. I don't think, yep, it didn't do that. Make sure you also apply your UVs, or else that's going to be another problem. That way it knows where the tiling is. Okay, there we go. That looks pretty good. So this is actually using the actual, if you actually look far over here, you'll see that it's flat. And then we start to get closer, that is actually now starting to apply the tessellation on top. So we'll hit play. We have our character, but we already see right off the bat that his feet are kind of sinking into the mesh, which that's actually not good. So let's go in here and let's go to our offset and let's make it a -1 because you actually bring down our offset a bit. Do that. See, that's a lot better now. So he's actually right on top of the mesh. If I want to, I can even adjust the contrast of it, like say 0.5. And it actually tries to like sharpen and bring down some of the values a bit. But be very wary that you can actually kind of see that contrast. Maybe up your tessellation just a little bit. And then maybe bring your intensity down. Like, let's do 7. Hit play. And as you can see, it's also doing the same thing where, actually, let me get closer to this. You can also see that it's doing the same thing as the parallax occlusion, where it's kind of giving off that edging that you would get. But instead of it is trying to figure out with math, this is actually using it with an actual mesh value. But the good thing is that you want to have a nice smooth transition for this guy, or else it's going to be very noticeable and it's going to make pops whenever you have this happen. But again, like I said before, make sure like when you're testing this, test it out in how you're going to view it as a character or as a player. Because if your player is going to be like this is perfectly fine. If you're using a surface that like the player has to get like really close with, like this, or if you're in a first person game and the tessellation has weird popping and weird issues where you see like artifacts and stuff, like even from this low angle, you'll see that there's like no cracking, there's no pops, there's no Z fighting issues. This is what you want when it comes to this. And remember to be very sparingly when it comes to tessellation and displacement. It's a very expensive thing. If you're using this as like every tileable material's using it on like a mesh that has like 1,000 triangles, your game's not going to run. It really will not. What people do is they'll either use two ways with tessellation displacement, where they either create like a mid proxy mesh of like some tileable mesh, like they'll have like a rubble tileable material, and then they'll just grab like a sphere or something, and they'll make some adjustments to the vertices, and then they'll apply some tessellation on it and make like a quick debris asset, or they'll just like grab like a very small sphere, apply the shader to it, and then like that's the only time you'll use like tessellation is for those kind of small details that you want to add for set dressing, but nothing like this. This is where you would bring in like bump, parallax occlusion, or even like bump map offset stuff. So I can already notice right off the bat that my engine's kind of running a little chuggy because of how the tessellation is, because that's pretty dense. But yeah, that's essentially tessellation and displacement.